Hey everyone, this note is on determining the function given a graph. So this time we are going to look at a graph, pull out the information, and then find our equation. Last video, we looked at the equation, pulled out the information, and drew our graph. So we're just going backwards this time. So just a reminder that the general equation is going to be as follows. And also just a reminder that it could be sine or cosine. Just a refresher that A is the amplitude, K is the scale factor, which will help you to find the period, or you can use the period to help you find the K value. The D is the phase shift, how much it's moving left and right by, and then the C is the axis, how much it's shifted up or down by. So if you notice in this example, the maximum value that we are looking at right here is 3. Okay, so our max is 3, and then our min is -1. And if I average those two numbers together, it will tell me where the midway point is on my graph, right? So to find my axis, I just average these two values together. So I'm going to add 3 and -1, divide that by 2. So I get 2 over 2, which is 1. So my axis is at y equals 1. And that should make sense to you because this right here is the point, like the line of symmetry that cuts the graph in half, okay? The amplitude, there's two different ways you can figure it out. Once you know the axis, you can say, well, this goes up by 2 and this goes down by 2. So that means that my amplitude has to be equal to 2. By the way, when we say y equals 1, that means that our c value is 1 in this equation right here. Another way to find the amplitude is you can find the difference between the two values, the max and the min, and then divide by 2. So I do 3 minus -1, which is 4 divided by 2, so I get 2. So my amplitude here is 2. All right, so now for the period. It's the period we're trying to figure out, well, how long does it take to complete one full cycle? So in this example right here, we are at our max, and we end at our max. And if you look right here, this would take 10 seconds. So our period here is 10 seconds. It takes 10 seconds to complete one full cycle. Another 10 seconds would be another full cycle. Another 10 seconds would be another full cycle. And to be honest, you don't have to start at the peak of the cycle and end at the peak. So I could start at the trough of the cycle and end at the trough. And I can see here that this is still 10 seconds because it went from 5 to 15 seconds, okay? I can even go from axis to axis if I want to, but here it's not as clear. Okay, cool. So now that I know that my period is 10 seconds, we can use that value to find our K value. So do not forget right here that our K value is always going to be 2 pi over the period. And here our period is 10. So our K value is going to be pi over 5. So that's going to be useful to us when we're ready to find our equation, because now we've figured out the amplitude, the K value, the C value, and now all that's left is the phase shift. But the phase shift is a little bit trickier because it depends on what type of a function you're trying to use, whether you're using sine or cosine, negative sine or negative cosine. And if you notice, it says that we need to find equations, so several equations. For starters, I just want to remind you that sine, positive sine, will look like this. Positive cosine will look like this. Negative sine will look like this. Oh, sorry, this is positive cosine. This is negative sine. And then negative cosine will look like this. So sine always starts on the axis. Whether if it's positive, it goes up. If it's negative, it goes down. Cosine always starts on the max if it's positive, or the min if it's negative. So in this example right here, our graph right here is starting at the max. Okay, so for the phase shift, I'm just going to write down depends on the parent. Okay, so here, if we're starting at the max, then we would use a positive cosine. So if we have a positive cosine, then that means that our phase shift would be equal to 0. Okay, so right here, one possible equation that I would have would be y equals, or f of x equals, we know that a is 2, and I'm not going to use sine this time. I'm going to use cosine because we know that the phase shift is 0 when it's positive cosine. of, and then I'm going to put the k value in here, which is pi over 5. And then there's no phase shift, so I'm just going to put times x. I don't need to put a minus d because there's no, the d value here is 0. And then I would just say plus 1 because our c value is 1, okay? Another option that I have is to instead start at the minimum. So if I'm going to start at the minimum, that means that I'm doing a negative cosine graph. Sorry, I forgot to write down that this is negative cosine. So here, when I have a negative cosine graph, if that's where I'm starting at, then I can see here that my phase shift, instead, it's starting 5 units to the right. So normally you would start at time 0, right? And it would look like this. But now because it is starting at time 5 seconds, our phase shift is 5 to the right. So it is a positive 5. So then if I want to write this out, then I would say y equals, now because this is a negative cosine and the amplitude is 2, then I would say negative 2 times the cosine of, and then here we've got the k value, which is pi over 5. And then I'm going to say times x minus, and then here our phase shift is 5. So I'm going to say minus 5 because that is the d value. And then I'm going to write plus 1 at the end. And then you also have the option of distributing that k value through, although it's not necessary. Both of these are saying the exact same thing. So let's go to Desmos, and I want you to see how these two equations are in fact the exact same equation as each other, or I guess these three equations. They're going to look exactly the same. They both represent this function right here. Okay, so I'll go ahead and type this in. So I'm going to say y equals, by the way, in Desmos, you have to make sure that you are also in radian mode as well, if we're doing our graph right here. So I'll type in right here, y equals 2 times the cosine of pi over 5 x, and then I'm going to close my bracket, and then plus 1. And if you see right here, this function is exactly the same function that we had before in our graph right here, okay? Then I'll type in the second equation. So the second equation is y equals negative 2 cosine of pi over 5, and then times x minus 5, or you could also just distribute it through plus 1. And if you notice, they're the exact same equation right here. And then again, if you wanted to, you could have just distributed that through. So I could have just said pi over 5 times x minus pi. And these are the exact same equations, okay? I just want to talk about how to find one that has sine instead. So to find sine, we have a few options. So our first option is, remember, our axis is at 1 and sine always starts on the axis. But this one right here, if this was my phase shift right here, if I was saying that this moved this much to the right and this is my starting point, then I wouldn't be using positive sine, I'd be using negative sine, because negative sine starts on the axis and moves down, okay? So let's just put this over here. So if I have negative sine, that means that my phase shift would, now it's really hard for me to see exactly what my phase shift is here, but we also know the critical point, like the critical interval. The critical interval will help us out. So if our period is 10, and our critical interval breaks up one sine graph into the 4 critical intervals right here, 1, 2, 3, and 4, then our phase shift would be a quarter of 10. I'm taking 10 and dividing it by 4. So our critical interval, let's write right here, our critical interval is 10 divided by 4, which is 2.5. So that tells us here that this has shifted over by 2.5. So our phase shift here is 2.5. And now that I've done that, I can go ahead and write out my whole entire equation. So nothing's really changed. Because it's negative sine, I'm going to write negative 2 for my a value, times the sine of, everything else is the same, pi over 5, times x minus 2.5, and then plus 1. So let's see if this really works. And yes, it does work. It's exactly the same as all the other ones. I'm going to ask you to find the equation, a possible equation. There's infinite possible equations, but find a possible equation with a positive sign, okay? And we'll check next. All right, in example number 2, this one is a little bit different because we can only see the minimum. We can't see the maximum, but we can also see the axis right here. So we know that the equation of our axis right here is going to be at y equals 2. So that means that our c value is equal to 2. Okay, and from there we can find that our amplitude is 2 because this is 2 away from the axis. Okay, so we know that our amplitude is 2, so a equals 2. Okay, well, if I can't see a full interval right here, then what I need to do here is find my critical interval. Like if I can't see the full period, then I would find my critical interval first. So if you look right here, my critical interval, this right here is a quarter of a cycle. So we know that our critical interval is going to be equal to pi over 6. Okay, so if my critical interval is pi over 6, then we know that that's a quarter of the period. So we know that the period is 4 times larger. So that means that the period is 4 pi over 6, or just simply 2 pi over 3. So here our period is 2 pi over 3, which means that I have to now find my k value. And my k value is going to be 2 pi over 3. So I'm going to multiply by 3 to cancel those 3's out. So I get 6 pi over 2 pi, which is 3. So here, the k value would have to be equal to 3, which should make sense to you because if the k value is, which should make sense to you because if the period is 2 pi over k and k is 3, then the period would be 2 pi over 3. Okay, cool. Now, again, the phase shift depends on the type of function, the parent function that we're going to use. So let's talk about what happens if you have no phase shift right here. So remember, this is the equation of our axis. So this right here is going to be sign, but positive sign increases and negative sign decreases. So this is clearly going to be negative sign. So when we have negative sign, then we are going to have a phase shift of 0. So the D here would be 0. Okay, so let's go ahead and fill in all of our information. So remember, y equals, we take the a value, which is 2, but because this is negative sign, we're going to say that this is negative 2. So we'll have negative 2 times the sign of, and then we put in the k value, which we know is 3. And then because there's no d value, the d value is 0, we're just going to say 3x. And then I'm just going to add the vertical shift, which is 2. The c value is 2. The equation of my axis is at 2. And then this right here would be one possible equation, okay? Another possible equation is to start at this critical point right here, which is the minimum right here. And if this is the minimum is my starting point now, that means that we are starting, we're going to use negative cosine. So right here, what would happen if I used negative cosine? Well, that would mean that my phase shift would have to be equal to this pi over 6 that we see right here. So when I go ahead and write out my equation, everything is going to be the same. Even the a value here is going to be negative because we're talking about negative cosine. So it'd be negative 2 times the sine of, the k value here is 3. We are going to do x minus the phase shift, which is pi over 6. I'll just make this minus here so it doesn't look like the phase shift is a negative pi over 6, and then add the 2. Okay, and then lastly, let's talk about if we were to start here instead. So let's say we were to start here, and this time with this question right here, by the way, let me just box this right answer. This time, my phase shift right here would be pi over 3. So if because it's starting on the axis and going up, this is a positive sign. So here our phase shift would be pi over 3, which is double the critical interval because right here, this is 2 critical intervals past 0, okay? So right here, because it's a positive sign, I'm going to put a positive 2, then I'm going to say sine of, and then I'll put the 3 here, and then I'll say x minus, and then my phase shift here is pi over 3. Close my brackets, and then I'm just going to say plus 2. And that would be my equation as well. And just a reminder that if you want to, you absolutely can distribute that 3 through if you'd like. Okay, so I want you to see if you can figure out what the equation would be for positive cosine, one possible equation for positive cosine, and we will talk about that in class as well. So for starters, I'm actually gonna make sure that I plot out these 3 points on Desmos to make sure that I have them going through the right points. So 0, 2, pi over 6, 0, and pi over 3, 2. So we have our 3 points right here. Let's go ahead and write out our first equation. So our first equation was y equals negative 2 sine of 3x, and then plus, close our bracket, and then plus 2. And our graph definitely goes through those 3 points. Okay, cool. Let's do our next one. So it was y equals negative 2 cosine of 3, and then bracket x minus pi over 6 plus 2. Works. Excellent. So then we have y equals, the last one was y equals 2 sine of 3 times x minus pi over 3 plus 2. And we are good to go for all of this. That's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.